Hello dear students, in this video we are familiar with T flip-flop, the triggering of flip-flop, that is two type, level triggering and edge triggering, and in the last we familiar with the rest around condition of JK flip-flop and outcome of these problems. Okay, let's start with T flip-flop. T flip-flop has a single input. The output of T flip-flop is same as the previous output or complement of the previous output. That is the T having the one input and that is the clock, and having the two output, that is the Q and Q bar, normal and inverted output. Let's start truth table. Truth table with clock 0 having the no change, that is the flip-flop is disabled, and with the clock equal to 1 and the T, that is the input, having the true value may be 0 and maybe 1. If it is 0, the output is no change. If it is 1, it means it is toggle of the present state, that is Q and bar. T flip-flop is obtained simply from the JK flip-flop tied together or shorting the JK flip-flop, like in this circuit. J and K, we draw first J and K with Q or Q bar as the output and JK as the input with the clock. Now if we short the J or K like this, that is called T flip-flop. Okay, when T equal to 1 means here T equal to 1 means J and K equal to 1 in this flip-flop, and when in this condition J or K flip-flop, we know the output is Q and bar, that is the toggle of the Q and present state. And when T equal to 0, J and K is also 0 in this circuit, so there is no change of the state at the application of clock pulse. It means the T input is 1 and clock signal is applied, then output will be toggle, that will be opposite to previous state, that is Q and bar. Okay, characteristic table of the T flip-flop using the truth table. Okay, characteristic table contains our inputs, present state and the next state. Dear students, remember the content of the characteristic table of the JK flip-flop. T having the 0 and 1 combination, with present state may be 0 or 1 for both combinations. So output T equal to 0, the output is 0. T equal to 0, the output equal to Q, and that is a 0 or 1. And T equal to 1 means J or K equal to 1, the output is toggle, that is a Q and here 0, so output equal to 1, and Q n equal to 1, so it is toggle, that is Q and bar should be 0. Next one, we draw the timing diagram with the clock signal, it having the one clock and one T signal, that is the clock is high, T is 0. Okay, the output is 0. In this period the clock is high, goes to high, so change here we can say change T equal to 1. T equal to 1, it means it is toggle the Q1 here the Qn equal to 0, so it may be 1, and so on. We can construct the full timing diagram of the T flip-flop. Okay, up to T flip-flop we are familiar with all type of flip-flop. First one SR flip-flop, then D flip-flop, then JK flip-flop, and lastly T flip-flop. Okay, next is triggering of the flip-flop. Students, what is the meaning of triggering? Triggering is giving the input of flip-flop, means the process of change the state of any flip-flop by applying the clock signal. Okay, that is the triggering. There are two types. First one is level triggering and second one is edge triggering. What is the difference, or what is the main difference of level or edge triggering? In the level triggering, the input signal affect the flip-flop only when the clock pulse is at logic 1 level. Okay, this is the level, that is a positive level. This is called positive level, and this is called negative level. Okay, next one is edge triggering. What is the edge triggering? Any plus have the edge and level. Okay, this is called the edge and this is called the levels. Okay, this is the edge triggering. means clock change from 0 to 1 and 1 to 0. Whenever clock is changed from 0 to 1 is known as positive triggering. If clock period having this one, okay? So 0 to 1, the clock is changed here, and this is also 0 to 1. Next clock is starting from this point. This is called positive age. If clock is like this change 1 to 0 and next clock period is start from this 1 to 0, it is called negative age triggering. So both age triggering and level triggering are used in the clock as a flip-flops. Okay. What is the procedure or what is the differentiate between these by the designing ASR flip-flop? This is the positive age triggering. Okay, see here negative age triggering by the bubble. Okay, with the clock, this is the negative age triggering of the flip-flop. So student, before solving any problem of flip-flop, be careful, see the type of triggering, that is the positive triggering or negative triggering, on positive as triggering or negative as triggering. Okay, next topic is rest around condition of JK flip-flop. We know that GK flip-flop having the condition J equal to 1, K equal to 1, the output is toggled, that is the Q and bar. Okay, when Q and bar is equal to 1 is solve the problem of SR flip-flop, that is the invalid or forbidden. But what happen when it is J or K equal to 1, the output is toggled, but that is the Q and bar. Okay, but this toggle continue 1 0 1 0 1 0. Okay, when the width of the clock pulse is greater than the propagation delay, that is the delta t of any flip-flop. When clock becomes 0, the output is unpredictable. It may be 0 or it may be 1. Let's start. I explain in this circuit. There is the JK flip-flop using the NOR gates. The output of Q is going to J and Q bar is going to K. Whenever J or K with clock equal to 1, the output is toggle, that is a Qn equal to 1. Means this is the width of clock pulse is greater than the delta t. Delta t means propagation delay, that is the delta t is less than the t, that is the propagation, that is the width of t is very large than the propagation delay t. So what happened, the output of Qn in this condition J and K equal to 1, it continue toggle between the 0 1 and 0 1 and 0 1 until the clock is going to 0. Okay, delta t here, that is Q and that is the 1, that is 0, that is 1, that is 0. It is continue toggle between the 0 or 1 until our clock is reached to 0. This is called rest around condition. Means here the rest between the output of Qn, that is the toggles of Qn, that it may be 0 or 1. So it is called rest around condition of JK flip-flop. For JK rest around condition avoided, maybe if first option is if delay of flip-flop is increased. But what happens if we increase delta t, that is the delay of flip-flop is increased, then speed of the system is decreased. So it is not proper solution of avoid the rest around condition of the JK flip-flop. Next option maybe because this condition is always happen in level trigger circuits, so we can use as triggered circuit. And third one is another solution of JK rest around condition is master slaves mode of JK flip-flop. In master slave JK mode, we having the two JK flip-flop. First one act as a master and another one is slave. In this circuit we can say master is directly connected to clock signal whenever slave is connected inverted clock of this inverted clock to the input of JK flip-flop as a slaves. What happen whenever change clock is equal to 1, the master is unable and clock is inverted, or that is the 0. so slave is not activated at the same time. So we can remove the rest around condition by this situation or by this solution. Okay, next video we can read out the characteristic equations of the all flip-flop. The lecture is very important. Next lecture is very important, in which characteristic equations of flip-flops we can construct.